Alright, so doing some soldering the other day on the Z80 computer, so just thought I'd do some videos. So this is a LiPo controller, load sharing charger, QFN20, so solder pasted it, and that works well. You can give it a little wiggle when you're done, and if it pops back into place, you're probably good. It's probably got good contact underneath. And then here's a 5-volt boost chip. That's the one on the right, buried in solder paste. Used way too much solder paste, and it ended up causing some shorts underneath, I think. But the reflow is pretty good. Got some bubbles there on the side that I'll clean up later, but I'm going to do that one by hand from now on. And then this is a little 16 megahertz crystal, and like a QFN, the pads are underneath, so that works best with hot air, and it lines up nicely, and no fuss, no muss. So here's that 5-volt boost chip that I ended up with lots of solder blobs, and you can also see I forgot to solder my inductor in. That's what caused me a lot of problems down the road. But anyway, before discovering that, I went ahead and cleaned up the results of having too much solder paste. So lots of flux on the sides of these chips, and good hot iron, and just sort of drag along the pins, and those solder blobs will clean right up, kind of like magic. Unfortunately, like I say, I think I ended up with some shorts underneath this package because it ended up not working, and it took a few reworks to get it soldered correctly with the big inductor underneath it. The QFN, on the other hand, worked great first time, so just cleaned these up, lingered a little longer on some of the pins just to make sure there's some contact there, and this worked perfectly on the first try, so that was an improvement over my previous build, and very easy to clean up these bridges on the QFN. Just use a lot of flux, and there's really no desire of the solder to stick anywhere except on the pins themselves. And then this is a FIDI 231. This is the serial communication device, so it reads from a USB port. And I tried something different here. I tried lining it up first and then slathering it with flux instead of putting the flux on the board first. That was something I'd seen done in videos, and it seemed like a good idea, but it made it really hard for me to get the pins aligned as nicely as I would like. So even though this worked fine, when it was done, the pins were a little bit misaligned, and that's not ideal. But it basically worked, and it's the same technique for drag soldering. Just put some solder on the tip of your iron, hold the chip in place, and just run the iron along the pins, and because of the flux it will adhere to the pins, and it will not adhere in between, except when you get a little bridge. But bridges are no problem. Just drag outward or along the pins, and the bridges go away. You can see my inductor sitting there on the top right. It's a giant inductor for the 5-volt boost, and that got soldered with hot air, but needed to be removed. I'll show you that in a little bit. Anyway, then soldering the other side is pretty straightforward. Throw down some flux, and the chip's already attached to the board, and then just drag some solder along the pins, and a very easy way to solder a chip with lots of leads without having to do each one individually. So here's some small components, just some 06, 03 resistor, some 08, 05 LEDs, and I've been doing these under a magnifying glass with a board holder instead of the microscope, but I put them under the scope just to get the video here. But pretty easy to solder these now. This was really difficult for me when I started, but lots of flux, good temperature for the iron, good healthy dab of solder on the tip of the iron, and you really just kind of touch it, and it adheres. Now this LED gave me a little trouble. It took a few tries because I didn't have enough solder, and I probably needed more flux, but after a few tries, got a good dab of solder to go on right there. And that's really all there is to these surface mount components. So here's some 0805 capacitors. Those are pretty big as far as surface mount devices go, but you can see you just kind of touch it. Doesn't have to be precisely lined up. This one I moved a little just to try to get some pad exposed on both sides, but you just kind of dab it and it sticks. And once one side is adhered, you don't really need to hold it to do the other one. Now for really small like 0402s, there might be enough thermal transfer that soldering the second side could melt the first side's connection, but not really an issue here. So so that's pretty easy. And the LEDs came out pretty good. So let me show you what you're dealing with LEDs. So this is a typical LED chip. Again, this is an 0805. It's pretty big. But when you flip it over, you see this little symbol on the back. And where that little green notch sticks out to the side, that's pointing towards the cathode. So the negative end that goes to ground, which should be on the left of my board. So I put it on the left, flip the chip over carefully, and then without changing the orientation, place it into the solder paste. So those are my charge indicators: power good, charge, and done. I already placed 2 of those, and then just placing the third one. And then the same thing, just put a little solder on there and adhere them. Now you can see the power good LED on the left is a different type of LED, and that's actually got a green dot on the left that you can see from the front to indicate which side is the cathode or the negative side. And then same business as usual, put some solder on your iron and hold down the component and just dab a little bit. This first one I did with the iron upside down from usual. That worked just as well. I usually do it in this orientation, so the flat side is coming in on the edge of the device. Doesn't seem to be super critical, which is, you know, the real surprise to me, because I spent so much time trying to figure out the right way to do this. And like so many things, experiment with it, find what works. That's the right way. And you know, this came out working really well. Plenty of solder there to make electrical contact. Cleaned it up pretty aggressively with a scrub and some alcohol afterwards, and you know, they stayed in place. So next was the power switch. There's 2 of these slide switches, one for power, one for turning on the Wi-Fi. So lots of flux as usual. I'm going to put that on a t-shirt, I think. And here's the switch. And it's got, you know, 3 contacts on the bottom and then 4 tabs on the side just to help attach it to the board. But it's those 2 connections on the left at the bottom that I really use because it's a single pole double throw. I only need an SPST, so hold it in place. And here, you know, just linger a little longer before moving the iron away, and you get a nice nice blob of solder connecting it to the pad on the PCB, and that'll keep it from going anywhere. And then do the same thing for the electrical connections, and then hit the tabs on the other side to further adhere it. And that's pretty much all you need. So that'll be a good solid connection, and it's not going to go anywhere. And then, as I said, my power boost had a problem, so I had to remove the inductor in order to get to the chip. So when the solder melts, the inductor moves, and you can lift off the chip, and you're good to go. I eventually figured out that what I need to do is attach the inductor with hot air first, and then solder in that little 6-legged power boost chip by hand, and then solder in the surrounding caps and resistors by hand also. And when I did that, everything worked great. All right, there we go. Thanks for watching. Bye.